Alright, so for those of you who've been following along with all of my videos, thanks. But we're going to do some more story problems here in this section. 2.7, more story problems. I know everybody's really excited, which means I know you're not, but hang in there. You can do this. Alright, so before we jump into any story problems, and I actually have two that I want to show you guys here in this section, we have to get an idea in our heads first. So this idea is the idea of consecutive integers or consecutive even and odd integers. So consecutive integers are just nice numbers that all fall in a row. I use 9, 10, 11 here as an example. They could be negative, they could be positive, they could really be anything, but they're in a row. Okay, 9, 10, 11. And so we can actually have a pattern for these using x's, which is going to be super helpful when we get into story problems. And that pattern is just simply that if the first one is x, the next one is x plus 1, x plus 2. You can keep going for however many of these you need. But basically they form a pattern that goes up by 1 every single time. Now, for consecutive even or odd integers, I have them grouped together, and we'll see why here in just a second. But the pattern is something like 6, 8, and 10, right? Those are even numbers, anything divisible by 2. And for odds, something like 7, 9, and 11. Again, they can be positive, they can be negative, it really doesn't matter. But they're going to proceed the same way. Now, the important thing here is to notice this. For the even numbers, we're going up by 2 each time, right? From 6 to 8 to 10, and so on. But that's also what we're doing for the odd numbers, from 7 to 9 to 11, and so on. So both of these work with the same pattern. X for the first one, and then x plus 2, x plus 4, and just continuing to go up by 2 each time. So regular consecutive integers go up by 1 each time. Evens and odds both go up by 2. So sometimes that really messes people up with the odds because you're like, hey, they're odd numbers. There shouldn't be any 2's in there. But the pattern still works the same because you're still going up by 2 each time. All right, so now that we have this, I'm going to do an example where we use consecutive even or odd integers. One of these things. And yeah, then we'll get on to some other stuff. Okay, so here we have an example for regular consecutive integers. Evens and odds would work the same way, just a different pattern again. So the sum of 3 consecutive integers is negative 48. Find the numbers. So we know a sum is addition, so we're going to be adding these 3 things together to get negative 48. And let's look at maybe how we're going to set this up. So with consecutive integers, I just like to first lay out how many do I have. I have 3 of them, so I have a first number, a second number, and a third number. I'm going to call the first one x. And because these are consecutive integers, just regular consecutive integers, I know that they go up by 1. So my second one is x plus 1, and my third one is x plus 2. Again, we could continue that pattern if we needed 4 or 5. We don't, though. We only need 3. So the sum of those 3 things, that's what I have written down here for the equation. X is my first one, plus x plus 1 is the second one, plus x plus 2 is the third one. Those 3 things added together equal the negative 48. And now, that's just a nice little equation to solve. I combine my like terms. X, x, and x make 3x. 1 and 2 also makes 3. I subtract the 3 from both sides, which gives me negative 51. And then when I divide by 3, I get negative 17. And now we're basically done. Okay, we have an answer of negative 17, but we need all 3 numbers. Be a little bit careful. Sometimes people go negative 17, negative 18, negative 19, right? 17, 18, 19, they're all in a row. Unfortunately, because these are negatives, you would be going backwards, and it wouldn't add up. So remember, we have this back over here. So if the first one is negative 17, the second one will be negative 17 plus 1, which is negative 16. And the third one would be negative 17 plus 2, which is negative 15. Okay, so there you go. There's nowhere good to stand. There you go. There's an example of how you can use consecutive integers and do those sorts of problems. And I have one more example to show you. Okay, so I don't actually have the example on the board yet for my last problem, but I have some information that we're going to need to do the problem first. So we're going to be doing an interest problem last here. Simple interest is I is equal, it has a formula. I is equal to P times R times T. And so you can see I've laid out what all those letters mean for us here. I'll talk through them a little bit. I is the interest earned. So let's pretend you're investing money. It's way more fun than talking about taking out a loan. So you invest a little bit of money. I is going to be the money the bank gives you for, the privilege of using your money. So I is interest earned. P is what's called principal. It's the starting amount. So if you invested $50 into an account, that would be your principal. R is the interest rate as a decimal. And you'll see actually over here, I kind of did an example for interest rate. I have a 6% interest rate. That's going to be 0.06 when we put it into the equation. It has to be a decimal. Okay, if you use 6, you're basically using actually there's no basically, you are using a 600% interest rate, which, no, that just doesn't happen. Well, it might, but if it does, it's probably either very short-lived and not really going to show up here, or probably illegal, so you're not going to get a 600% interest rate. Anyway, and then T is the time measured in years. Now this is important. 6 months would be half of a year, right? 6 out of 12. So T has to be measured in years. The good news is, for the problems that we're going to be doing, T is always going to be 1, and that's really going to simplify things. All right, so let me get the example on the board, and we'll go ahead and do it. All right, so here's my last story problem. It's kind of a doozy. You'll notice I took really the entire board to try and get this one up here for you. So let's start it, and ignore my equation down here for a second because that's obviously a little bit later in the problem. First we have to get the equation. All right, so let's read this problem out. You invest money at 6% interest and $1,500 more than that at 9% interest. If the total interest after 1 year is $435, how much did you invest in each? Okay, so here's where I started. And here's where I would always start with these. Again, I need a letter for one of the two things, and then I need to express the other one using that same letter. So in this case, I noticed that there's more money in the 9% account, right? That's what we're told over there. So I called the 6% X and 9% X plus $1,500 because I know that's how much more there is in that 9% account. Now, obviously you can already see my answers there, but that's okay. So here's where I went from there though. I know that the formula is I is equal to P times R times T. Well, the length of time is just 1 year, so I don't really have to worry about that because what's 1 times anything? Whatever you started with. So I basically just take my interest rate times X and my interest rate times X plus 1,500. Okay? Again, they have to be decimals, so my 6% turns into 0.06 times X, and then 0.09 plus X plus 1,500. And what we have there is we have the interest from each of them, and if we add them together, it has to equal that $435. So you can see all my algebra here. Oh, I kind of erased part of it. That's not good, but we'll get to that. So I distribute the 0.09, which gets me 435 is equal to 0.06x plus 0.09x plus 135. Combine my like terms to give me 0.15, and then subtract 135 from both sides, which gives me 300, and that's what I accidentally erased here. There we go. And finally, I divide both sides by 0.15 to get 2,000 for x. Again, don't stop there, right? Once you have x is 2,000, that's great, but you have to finish the problem. We wanted to know how much was invested in both. So you just have to go back and add that $1,500 on to figure out that the 9% was $3,500. Now, this is really, it happens way more often than I even want to think about, that people just stop there. Please don't do that. It's just really, really sad, especially if you're taking one of my tests. I will take a point off. I'll be like, oh man, you were so close. And yeah, just don't do that. Bad idea. So anyway, there you go. That's story problems. Good luck with all of them, and have a good day.